Welcome to the lecture series Programming in C. In this series, today's session we will be looking about two-dimensional arrays. We have already learned in the previous session about the one-dimensional arrays. Anyways, I will refresh it. The arrays are the data structures which are able to store data types of same type, and it can hold the collection of elements in a contiguous array locations. We are now going to learn about the two-dimensional arrays. In what way two-dimensional arrays are going to help us more than a one-dimensional array. So, we will be learning about the definition and example of 2D arrays in this module and how the two-dimensional arrays are being processed and operated on various scenarios with respective examples. So, on definition, a two-dimensional array is also named as a 2D array, is a collection of data elements arranged in a grid-like structure with rows and columns. Already we have learnt that in the case of one-dimensional array, it was just single row with n number of elements stored in a contiguous memory locations. Here in the case of two-dimensional arrays, if we want to create it as a table format or a grid format, which is not possible with the 1D arrays. So, we are moving on 2D arrays, two-dimensional arrays with rows and columns defined. So, here we can see in the screen an example that it has 4 rows and 5 columns. So, if we want to create a grid like this with 4 rows and 5 columns, we can go for declaring it as a two-dimensional array which can hold up to the maximum of 20 values. So, 4 arrays and 5 columns. So, if we arrange it in the grid order, if we try to store the values into it, the number of values will be 4 into 5, which is 20 values. So, how we can declare a two-dimensional array? The syntax for the declaration of a two-dimensional array would be data type. We have to mention what is the type of data we are trying to store in the array, and the array name is a user defined name, and how many elements we can have it in row or how many rows we can have, and how many columns we can create the array with. So, these things can be mentioned in the form of general syntax. So, we can see the syntax applied to a few of the examples, like int is the data type, marks is the array name, 4 is the row size and 5 is the column size. If it is going to be 4 by 5, then we can store 4 into 5, that is 20 elements, which is actually stored in the figure. Then float data type, sales is the array name, and 12 is the number of rows and 25 is the number of columns. Supposing if we want to create a spreadsheet kind of processing structure for calculations, we can make use of such type of arrays with 12, I mean more number of rows and more number of columns. So, double is the data type, matrix is the array name, 100 is the row size and 100 is the column size. It means that we can create a matrix of 100 into 100, 100 by 100, which can all store double type values. So, in the figure we can see that the rows are going to be mentioned with the number value 0, 1, 2, 3, which is actually the index of the array. Again, the column values are represented using 0, 1, 2, 3, 4 values. The rows are going to be the routes that are going to be followed by a vehicle. The columns are going to be the days. So, on what days, what are the routes that are followed? If we want to represent this as a data structure, then we need to go for using it as a 2D array. Then similar to 1D array, here also we can make the same way of initialization by using the curly braces. So, here altogether we can make use of the same way of value initialization for a two dimensional array, which is represented as int a of 2 comma 3, which means that 2 rows and 3 columns. So, if we are just representing all the values all together, automatically the compiler will be able to differentiate how many number of elements are going to be in one column and how many are going to be in the next column. So, in the first row it can have the column values to be 1, 2, 3 because the column size is 3, and in the second row it can have column values to be 4, 5 and 6. So, the same initialization process can be done in a better way for user friendliness as using double curly braces like this. So, here one row element can be enclosed within a square braces, the other curly braces, the other set of row elements can be represented using curly braces. The altogether those two rows can be again enclosed within a curly braces. So, this way also we can initialize the values in a two dimensional array, where we need not specify the row size. Even if you are not specifying the row size, automatically the compiler will be able to assume that there are two curly braces, there are two set of values given. So, immediately it will be able to understand that the row size is 2. So, all of these three initialization statements will all be the same, and it will allow us to store the values in the form of two rows having 1, 2, 3 in one row and 4, 5, 6 represented in the second row. Okay. Now, we can learn how two dimensional arrays can be declared using how values can be passed on to the two dimensional array. So, we have already learnt the way that it is defined, it is declared. So, we will be using the general format for defining or declaring two dimensional array as this. Okay. On declaring this, how we are going to access or how we are going to supply values to the two dimensional array. So, we can use two subscripts. So, m will be the subscript 1, n will be the subscript 2. So, m represents the row value and n represents the column value. So, if we want to add two dimensional matrices or two dimensional arrays, so this is the way we can do A of I j, which represents an element in the array A with subscript I and subscript j, and B of j comma k represents the subscript value j and k for the array B. So, likewise we can have access to the elements of a two dimensional array using two subscripts, one for row and one for column representation, right. Now, we should understand when we are trying to access a two dimensional array, actually what happens and how the subscript elements are being ordered. Okay. So, starting from the values, say let us assume that this is the two dimensional array with 3 rows and 5 columns. If 3 rows and 5 columns are there, we will be accessing the array elements with two subscripts, since it is a two dimensional array. So, the subscript starts from 0 to 4 for the column representation and 0 to 2 for the row representation. So, the first element in the first row and first column would be represented using the array name here it is B of row subscript to be 0 and column subscript to be 0. So, the row index is 0, column index is also 0. So, that will denote the first element. So, B of 0 comma 0. So, row subscript is 0, column subscript is 0, that will represent the first element of the first row and first column. Supposing if I want to represent this element. So, what is the row number? Row number is 1, column number it is 3. So, then we have to represent this as row number to be 1 and column number to be 3. if I want to represent the last element of the array, last element is going to be 47. So, if I want to represent 47, the last element can be the last value of the subscript in the row value, which is 2, again last value of the subscript in the column, which is 4. Okay. So, last value it is 4, last value it is 2. So, last row, last column. So, that is represented using B of 2 comma 4. So, in the memory what happens, how it is being stored. So, that also we should understand. It stores the value row wise. It means that anyway the arrays are going to be the data structures which is going to store the value contiguously in the memory location. In what way the 2-dimensional arrays are handled? Row wise storage. So, what happens, the first row value starting from 2 to 11 will be stored initially, and then it goes ahead with the second row value starting from 13 to 29. You can see that it is a set of prime numbers. So, here we can see that B of 0 comma 0 will be taking up the first value, and it goes up to the value B of 0 comma 4, then it goes with the second row. So, second row is represented using the subscript 1 comma 1. So, 1 comma 1, and then it goes ahead with all elements up to B of 1 comma 4, and then it has to start with the next row starting from B of 2 comma 0, and it goes ahead. So, this is a way that the values are being stored in the memory. So, we can see that in the main memory the low address and the high address representation would be as usual carried out, right. So, now we should also be able to find that the memory location are stored contiguously row wise. So, here in case if the memory address is given to you, how to find out a particular element? It is by using this formula, where x will be the starting address of the array, I will be the row number, and j will be the column number, and k will be the number of bytes allocated per array element. So, using this we will be able to calculate the size of the array, right. So, let us take one more example for storing 2D array in memory. So, this is the way we are defining. It is an integer type 2-dimensional array. We also know that for an int type variable it takes 4 bytes for storage. Okay. Then we are going to have a loop starting from 0 to 3, since there are 3 rows, and inner loop will be from 0 to 5, since we are having 5 columns. And now we are trying to print the address values. Since we are trying to print the address values, we are not trying to print the values stored in that array. Instead, we are trying to print the address values of the array. So, we will be using the control string %u, %u ampersand a of I comma j. You can have a say clarification that why in printf we are using the ampersand symbol. Usually in scanf we used to have the ampersand symbol. Why ampersand in printf? It is that we are trying to print the address values of the elements. We are not trying to print the elements, instead the address value. So, here you are supposed to use %u and ampersand symbol, right. Now, we are trying to print statement in a loop. So, the first row first column will be accessed first. The first row first column address, it is 44480. Then it is incremented by 1. So, the next address will be after 4 bytes. So, after 4 bytes it is 84, then after 4 bytes it is 88. So, in the first row, that is in the subscript value, if it is 0, we start from printing from 0 to 4, having the row subscript value to be 0. So, 5 elements, and then we will have to increment the row subscript by 1. Again the loop starts from, the inner loop starts from 0 to 4, right. the third row will be using the index value 2 for row subscript, and again the inner loop will be incremented from 0 to 4 in order to represent 5 columns. So, this is the way the address will be accessed, and the array subscript will help us store and access the values. So, here we can see that there are 5 elements represented in a row, and the next set of 5 elements contiguously represented in the next row, the next set of 5 elements represented in the third row. So, this is how the number of rows, that is 3 rows and 5 column values will be stored in memory, right. We will explore more on the array addresses, how actually the 2-dimensional array is accessed. So, the same example we will take of having 3 rows and 5 columns. So, what I am trying to do, initially I am trying to print A with the control string %u. It means that the base address of the array A. So, we are assuming that the base address of the array is this, it is getting displayed, right. The next statement is we are trying to print the value of A of 0, 0, which means that the first row first column value. So, in which we are trying to print the first row first column value, which will be the same as the base address, right. Then I am trying to print the value of A of 2, 3. It means that in the we are trying to print the last row, third row fourth value. So, third row fourth value address will be displayed. So, that is what we are getting it displayed here, and you can see a small difference here, A of 2 plus 3. We are not using this notation, instead we are using the notation A of 2 plus 3. So, here we will be referring to A of 2, and from that 3 locations will be added, and you will be getting the location displayed as 532. It will be the same as A of 2, 3. Also, we can make use of another notation using the pointer, or pointer star will be the pointer operator, which will denote the address of that particular element. So, A plus 2, that is base address plus 2, whose address we are finding out, and then we are adding 3 with that, will again be the same address value. And similarly, we can even have asterisk A plus 2, which denotes actually 4520, which is actually A of 2, A of 2, 0. Since we are not giving any value for the column, automatically the 0 value or the first column value will be taken by default, and accordingly the address will be displayed. Since we are using all %u symbol, we will be getting only the address of the particular array element displayed. We are not trying to display the elements of the array. Instead, we are just trying to display the address where the particular element index is stored. Hope you would now be able to understand how the two-dimensional array is stored in the memory, and how we are able to access it according to the address storage. Now, how we can read the values of a two-dimensional array? We can make use of a 2 nested loops. So, the outer loop will be the one which is used for representing number of rows. How many number of rows you have, to that extent we have to use the control variable of that for loop. The inner loop will be to represent the column value. So, how many number of columns we have to use that for denoting the accessing up to that number of columns. So, for the example which we have considered here, instead of n row I can replace it with 3, instead of n column I can replace it with 5. So, doing this we will be able to get the values of the particular array stored using the for loop. So, 3 by 5, 15 elements we will be reading using the scanf statement, and same loop can be used for printing the elements row and column wise. So, starting with the first row, we will be executing the inner loop for column number of times, and then we will be using the printf statement for those many columns. So, having the first row execution, n number of columns execution will be completed, then if it is over, the next row will be incremented and it goes ahead with printing the elements of a table or elements of a two-dimensional array. So, here we can see that in the first case the elements will be of the columns. If at all if we want it to be displayed as a perfect table display, here we can go with introducing a \n, which will be giving a new line after completing the column entry. Say for example, in this case if n row is going to be 3 and n column is going to be 5, let me assume that I am going to enter the values in order of the natural numbers starting from 1 to n. So, the first row will be filled with 5 column values, and we are now giving a new line for displaying the second set of or second row values. So, like this. So, in case if you want to give a new line, you can make use of the \n symbol, or otherwise in the second type, if we want to go for the second type, it continues the display without even giving a new line like this. But this will not give the feel of a table. So, that is a reason that we go for using a \n, so that we can get it in the form of a table or grid structure. The elements can be printed in the form of proper table by even be able to give a space in between the numbers and then the \n for introducing the new line. So, this is a complete example that it creates a 3 by 4 matrix, 3 by 4 matrix. So, it creates a 3 by 4 matrix in the sense that it can have 3 rows and 4 columns, and we go for initializing the first 3 rows with 4 column values, and we are trying to display, we are using the 2 loops, nested loops, and here we can see that the row value is up to 3 and the column value is up to 4. So, we are using a printf statement of displaying the values of matrix of I comma j, and we are even introducing a \n the outer loop. So, obviously after completing the elements printed in a particular row, we go for introducing a new line and then it prints it in the form of a complete matrix. So, this example is to understand how matrix operations are being done with the help of a two-dimensional array, because two-dimensional array allows us to go with a grid structure. So, possibly for it is maximally used for matrix representation. So, here we can see the first loop is used for getting the values or reading the values of a matrix A. The second loop structure is used for reading the values of matrix B, and we can see that the same loop is used for adding the two matrices also. So, the simple operation here is C of P q equal to A of P q plus B of P q. So, it means that whenever we are using the loop structure for the row and column values, the same loop structure can be used here, because the subscript is going to be the same for matrix addition. Say for example, if you are going to add 2, 3 equal to, the same subscript is going to be there for both the matrices, or the same positions or corresponding positions are going to be added in both the matrices. So, that is the reason that we use the same control variable of the loop for all the matrix or all the two-dimensional arrays. So, after completing the addition, you would have got the values added in the C matrix. So, we are supposed to use the same looping structure for displaying the matrix values in the form of a matrix. So, we are using a \n character, and then we are trying to use the same loop for displaying the values of the resultant matrix which is there in C. So, this is a simple program to add two matrices and get it displayed in the form of a matrix structure. And if at all if we are using functions, can the 2D arrays be passed as parameters to the functions? Yes, it can be done. So, what we are supposed to do? We are supposed to just pass the array name as parameter. The starting address of the array would be passed as parameter to the function. So, here you can see a simple example. A is an array, B is also an array. So, which has to be passed as parameter to the particular function as A, B are the starting addresses of the array which are passed, and 5, 15 and 25 are going to be the row value and column value, which can even be passed as parameter to the function. So, we can see here that how the parameters are being received as formal arguments. The formal arguments are passed and the actual arguments are being received by the function, and it goes ahead with operating for the two dimensional arrays. So, summarizing on this session, we have learnt how two dimensional arrays can hold the values, can store the values in the form of a grid structure, how it can be maintained in the form of a table or tabular structure in the case of memory locations, how we can read, operate and print the two dimensional arrays, and how we can do some sort of minimal operations with two dimensional arrays. So, especially on matrix. So, we have seen those examples too. Thank you for listening to this sessions.